Hey guys, today we're going to take a look at polynomials in factored form. Now before we jump into our notes, let's just quick remember what factors are. Factors are two things that multiply together to get a product or the end result. So for example, if I give you the number 12, you could say that the factors of that would be 2 and 6 or 3 and 4. And to get back to 12, we would put them back together, right? That's called composing a number. When we compose a number, we combine two numbers through an operation. So if I take 2 and 6 and multiply them, I'll end up with 12. Same thing with 3 and 4. If I decompose a number, I pull its factors out of it. So if I decompose 12, I can pull out a 3 and a 4, or I could pull out a 2 and a 6. All right, and that's what we're going to be talking about today. Whenever we're talking about factored form, we are decomposing or we are pulling apart the smaller factors that are used to produce the larger polynomial. All right, so the first topic we're going to focus on is just greatest common factor. Remember, that's the largest factor that the terms of the polynomial have in common. And factors are simply the numbers that are multiplied together to equal the original value. Just like 2 and 6 were factors of 12, same with 3 and 4. Well, now we're going to have some numbers and variables. So let's take this standard form polynomial, 2x squared minus 8x. Let's decompose that into its factors. And when I say decompose, I'm looking to pull out the two factors that multiply together to get this 2x squared minus 8x. Well, if I look across these two factors, I'm going to pull out the greatest common factor, which is 2x. And you can see that we pull that 2x out, and what we're left with is what we would get if we took each one of these terms and divided it by 2x. So 2x squared divided by 2x gives me x, and then negative 8x divided by 2x gives me negative 4. So my two factors are 2x and x minus 4. Now, if I wanted to put these back together to check my work, then I would compose the polynomial, and I would do that by distributing that 2x to the x and the minus 4. And that would bring me back to 2x squared minus 8x. All right, example 1 simply is practicing finding this greatest common factor between two expressions. So these are monomials, and we want to look at their factors. And we can see that 4 would be broken down into either 1 and 4 or 2 and 2. 12 would be broken down into 1 and 12, 2 and 6, or 3 and 4. All right, now the greatest common, what do they both have in common? Well, that's 4. And we also need to look at the variables. So this has x to the 4th, which can be made up by saying x cubed times x. And this is just x cubed. So the greatest one that they have in common is x cubed. So here we would say that the GCF is simply 4x cubed. All right, in example 2, it gets a little bit trickier. Now we're going to try to find the greatest common factor of these two expressions. 3y minus 15 and 2y minus 10. So let's start with 3y minus 15. If I take a look at this binomial, I see that I can divide out a 3. I can break it down into its factors. And when I do that, I'm left with this 3 times the binomial y minus 5. Those are the two factors that this original polynomial decomposes into. All right, the next one is 2y minus 10. I see that in this binomial I can divide out a 2, and I'm left with 2 times y minus 5. All right, so here I have the factors for both of those polynomials. The greatest common factor is y minus 5. So I say that my GCF for these two binomials is the factor y minus 5. And I'll just put it in parentheses, although you don't need to. All right, let's take a look at example 3. It says to factor the following polynomials using GCF. All right, if I take a look at this first polynomial, this binomial, I see that 4 will divide out of both of those terms, And that's my greatest common number that I can pull out. And then I see that I have an x to the fourth and an x cubed. Well, the highest degree that both of these terms have in common is x cubed. So my GCF is 4x cubed. So there's one of my factors. Now, I do need to list my other factor. If I factor out a 4x cubed, what I'm going to be left with is x plus 6. And those are the two factors that this polynomial will decompose into. Again, another way to check that is just to redistribute your 4x cubed back into that binomial, and you should end up back where you began with 4x to the fourth plus 24x cubed. All right, example B for number 3. This should look familiar. We just did this one up top. I'm going to factor out a 2x, and I'll be left with x minus 4. All right, finally C, I have a trinomial, and if I look across all three terms, it looks like the greatest common factor in all three of these terms is going to be a 5x, because that's the largest power of x that each one of those three terms has. All right, now if I pull the 5x out, this is kind of like the reverse distributive property, right? You're dividing out a 5x. I'm going to be left with 5x squared minus 2x plus 1. All right, so there are the factors of this polynomial. All right, let's check out example 4. Example 4 is a rectangle that's broken up into 4 parts with the area of each of the smaller pieces written. We want to find the dimensions of the larger rectangle. All right, so this kind of goes back to a problem that we did earlier in this chapter. And how we're going to solve this is we're going to take a look across our rows and up our columns here, okay? So we're going to just ask ourselves, what's the greatest common factor of this row? Well, it looks like I can divide out a 3x. All right, let's go down to the bottom one. What can I divide out of this bottom row? It looks like they both have in common a positive 5. All right, next we're going to do the same thing, but now we're moving up the columns. All right, so between 6x squared and 10x, it looks like the greatest common factor there is 2x. And then finally between 15 and 9x, the greatest common factor there is positive 3. And believe it or not, this is the dimensions of that larger rectangle. It's a 2x plus 3 by 3x plus 5. And if you don't believe me, go ahead and remultiply that. 2x times 3x gives me 6x squared. 2x times 5 gives me 10x. 3 times 3x gives me 9x. And 3 times 5 gives me 15. So there you have it. Those are the dimensions of my larger rectangle. All right, one more example for today. We got the GCF of the following expressions. 6x squared minus 24 and 3x to the fourth minus 12x squared. All right, so let's take 6x squared minus 24 first. And we're going to factor out, it looks like we can factor out a 6. So that is going to come out here in the front. We got x squared minus 4. All right, now 6 can be factored further. You could say 2 times 3 times x squared minus 4 if you really wanted to. All right, well, let's go to the next one over here. We got 3x to the fourth minus 12x squared. Looks like I can factor out a 3x squared. And when I do that, I'm going to be left with just x squared minus 4. All right, so we're starting to see some patterns here. Now, this monomial here, 3x squared. Actually, I can rearrange that to be x squared times 3 times x squared minus 4. And now you can start to see where our greatest common factor is here. It is this 3 times the x squared minus 4. Now, there are two factors there, but yeah, they're common in both of those polynomials. All right, so that's what we're doing today. We are taking a look at polynomials and trying to decompose them by factoring out or dividing out the greatest common factor from all the terms.